For our final strategy, I think we'll just end with one example. We're talking here about expressions involving fractions, and our strategy, we can sort of classify it as combining fractions. Now, one of the best tips I can offer you here is that these problems can seem more difficult just by nature of the way they're expressed. We're going to be given problems that have this form. We're going to see a fraction expression minus another fraction expression, and all of that is going to be in the numerator of this overall fraction expression that has h in the denominator. And my suggestion is do a simple rewrite. And here's the purpose. Number one, it makes it look a little less complicated. Two, it helps us focus on what we're doing. And three, we remember our goal. Remember, our goal is always to fix the problem. And as we've seen in every other situation, the problem is that if we tried to plug in the denominator value of 0, we can't do it. And so I'm going to suggest that you take this dividing by h and rewrite that off to the side of your problem. So everything that's divided by h has now been brought off to the side, and everything that's in the numerator remains right here. And then with this in mind, our strategy focuses on combining these two fractions. We're going to combine those using all the normal techniques of getting a common denominator. And I can't promise you it'll be fun, but it should be a little bit more manageable. So let's just look at one example. Let's start with the limit as h approaches 0. Remember, the whole thing is over h. And let's have the numerator be 1 over 3 plus h minus 1 over 3. Like everything else we've seen, all of these problems are special because they relate to the work coming up as we develop the derivative. You can verify that if we plugged in 0, we get a third minus a third over 0, and we're back to the same situation. So let's follow my advice up above and rewrite this problem so that the dividing by h is sort of off to the side. That puts our focus here on essentially the numerator expression, and we want to combine those. Like we always do, we start by recognizing a least common denominator. And I know these seem closely related, but the truth is 3 plus h and 3 are not alike at all. And so our common denominator is going to be the product 3 times 3 plus h. And as we'll typically do for these things, we can multiply by 3 on the left fraction to get the fraction, the equivalent fraction that has that common denominator. And we'll multiply the top and bottom terms by 3 plus h on the right-hand fraction. And this is what we end up with. The limit as h goes to 0, 1 over h is off to the side, and I have 3 over 3 plus h minus 3 plus h. Oops, did I do it? I totally forgot my common denominator. 3 over 3 times 3 plus h minus 3 plus h over 3 times 3 plus h. And because those have a common denominator, then of course we can look at the numerator as one problem. Now, the main issue people have here is forgetting that we are subtracting a fraction, or really a group of terms. And so we really need this set of parentheses to keep track of this subtraction properly. Notice what's going to happen. 3 minus 3 minus h, or 3 minus 3 minus h. And in the end, here's where that brings us. We end up with a numerator of minus h over the common denominator of 3 times 3 plus h. And like we've seen before, the same thing that was our problem can be fixed with this factor of h that remains. That's just how these are going to work. When we divide those, we're left with -1 as our placeholder. And so now we can take what we have. Let me just rewrite it so it looks a little cleaner. -1 over 3 times 3 plus h. And we can evaluate this with direct substitution. And that gives us -1/9. You might need to try one or two more examples that are similar to this. Feel free to look in the textbook or on plenty of other websites for more practice, and just practice these skills.